Okay. Uh, is everything goes well?
Yes.
Okay. Okay, and let's start. Hi everyone, I'm Anqi from Zhejiang University. Today I will introduce our paper, Team Scouter, Simulative Visual Analysis of Soccer Player Scouting. In soccer, player scouting is to find suitable new players to strengthen the team. During recent years, professional clubs spend high transfer fees to obtain well-performed players. It is an important decision-making task for soccer team managers to increase the chance of winning future matches. Scouting suitable players for a team is a complicated task. For instance, there are a large number of expensive but ineffective player transfers in professional clubs. Such field transfers are mainly caused by the different tactical systems and teammates among the different teams, which leads to the different performance of the players. Thus, we introduce simulative analysis to soccer player scouting to estimate the player's performance in a new team. To evaluate whether the players will be suitable for the team, a series of studies have been proposed to evaluate player performance in historical performance, expected performance, and expected market value. However, these methods solely provide player performance indicators and seldom support the navigation and comparison of potential target players. Interactive visualization systems have been developed for an in-depth investigation of soccer match data, including team ranking analysis, team tactic analysis, and player evaluation. However, visual tools for simulative-based soccer player scouting are still rare. In this research, we propose a visualization system, Team Scouter, to provide a simulative visual analysis method for soccer player scouting. Users can select the player to be replaced and obtain the automatically recommended players and investigate players' simulated performance and the different onboard tactics. We face two main challenges during the system development. The first challenge is to provide fine-grained simulation for player behaviors in a new team. In soccer matches, player behaviors are related to both the player decision styles and the current team tactic. It is difficult to extract and integrate the complex features into the simulation of player behaviors. The second challenge is to develop effective visual tools to support player navigation and comparison. Experts need to identify the target players from hundreds of clubs in numerous leagues and compare their simulated behaviors to decide who is the most suitable for the team. The system should support such interactive analysis to find the suitable players efficiently. To solve the first challenge, we develop a two-level match simulation framework. The framework contains three components: player action prediction, match result prediction, and action score estimation to simulate both match results and player behaviors. To simulate player behaviors, we predict the action of the player with the current match state and calculate the score of the simulated action. The expected contribution of the player can be estimated by the increment of action value compared to the original player. The player action prediction model contains the player and team embedding and the sequential learning model. With the player and team embedding, the playing style of players and the tactic style of teams can be represented by the learned embedding vectors. The sequential learning model extracts the state feature with the transformer network and predicts the next action with the state feature vector and the embedding vectors. To simulate match results, we predict the match winning rate with the players in the match and the opponent team. The expected contribution of the player can be estimated by the increment of match winning rate compared to the lineup, including the original player. To solve the second challenge, we worked with three soccer experts and developed design requirements at three levels: team level navigation, player level comparison, and action level investigation. On team level navigation, we design a scoreboard in the navigation view to present all players by their roles and indicates the player will be replaced as the player recommendation reference. The scoreboard places the players with the same role together based on their spatial locations on the pitch. It is designed based on the metaphor of the team depth chart, which is familiar to soccer experts. As for the players in the same role, we rank the players by their appearance time to illustrate their importance and encode their market values as bar charts for effective comparison. In the scoreboard, users can identify the player who might be replaced by a new player. After specifying the scouting metric, the player ranking list will present automatically recommended players. On player-level comparison, we design a player ranking list in the navigation view to compare the recommended players on essential personal information and their performances. In the player ranking list, we present the recommended players with a sortable list to assist the comparison among the players. Each row of the list contains the player's age and market value, and the current team with a similarity to the analyzing team. They are the three most important player attributes influencing player scouting. The player ranking list also provides the historical performance and the expected performance of the player. The historical performance contains the total action values per 90 minutes and the appearance time of the players. The expected performance is the expected increment of the winning rate calculated by the match result prediction model. In the player ranking list, users can compare the players on their essential personal information, historical performance, and expected match result, and add potential target players to the investigation view. On action-level investigation, we design an investigation view, including an onboard tactic list to find the onboard tactic of interest, and the player record list and the simulated action map to illustrate the difference between the simulated actions and historical ones under the selected onboard tactic. The onboard tactic list presents the onboard tactics of the analyzing team with a sortable list. Each row of the list contains an onboard tactic map to represent the onboard tactic and the frequency and success rate for the onboard tactic. The onboard tactic map is a pitch-based visualization of onboard tactic consisting of an abstract spatial temporal trajectory and a heat map. The player record list records the potential target players selected in the navigation view. Each row in the list contains the average difference between the player's simulated actions and original ones, and the average action value increment. The simulated action map illustrates the spatial distribution of simulated actions and the selected onboard tactic. The simulated actions ended in the same grid in the pitch are aggregated and visualized by a glyph. The glyph presents the comparison results between the simulated and the original actions, including the frequency of the simulated actions, the average action value increment, and the average difference compared to the original actions. In the investigation view, users can find the onboard tactic of interest and compare the expected action scores of the players to decide the most suitable player. Users can further investigate the difference between the simulated actions and historical ones to understand the effect of the player. We evaluate the system usability with 2 case studies conducted by 2 experts respectively, including the analysis of 2 different top soccer clubs. After the case studies, we interviewed the experts respectively to collect their feedback. Both experts are satisfied with our system and provided several suggestions for improving the system. In conclusion, we characterized the domain problem of soccer player scouting, develop a match simulation framework, and design a visualization system to support simulative-based player scouting. In the future, we will integrate fine-grained soccer match data into match simulation and generalize our work to other team sports, such as basketball and ice hockey. I'm also seeking postdoc positions, so if you have any interest, please contact me. That concludes my presentation, and I'm happy to take any questions.
Thank you very much, Anqi.
Thank you.
Right. So let me kick off the round of questions. I'm interested in, do you have any ideas how to incorporate trajectory data? What would you expect to change? Would the simulation become more reliable, or what would be the expected results there?
Yeah, it's a really important question. We have done some experiments to evaluate the mesh simulation model, and so we try to um, increase the model accuracy, so we can simulate the match more accurately. And in the future, we will try to integrate more data such as the player trajectories, so we can make the simulation more reliable. Yeah.
Thank you very much.
Okay.
There is another question on Slido by Lucas. In reality, clubs will also look at young players with great potential. Real Madrid eventually obtained Mbappé, Vini, Endrick. How to fill this gap?
Yeah, I got this question. So in our system, we use the data of the European top leagues. So in our system, we cannot to find the young players in other leagues. So in the future, we will collect more data of the young players, and we can also collect their such as their match data and their performance data, so we can generalize our system in the future with more data. Yeah.
Yeah, perfect. Yeah, I
Okay.
assume most of them will come from smaller leagues, or many of them. Yeah, thanks for the question. And thanks for the very good presentation. We are moving on to the second paper, which is Sportify, question answering with embedded visualization and personified narratives for sports video. The presentation is going to be given by Chunggi Li, and the floor is yours.
Okay. Can you hear me and can you see my screen? Okay.
Yes, all good.
Good, sounds great. So good morning, everyone. Thank you for coming here. And I'm Chunggi Li, a PhD student in Harvard. I'm really excited to present the Sportify question answering with the embedded visualizations and personified narrative for the sports video. I'd like to thank to my excellent collaborator, Tica, Zhu-Tian, and my advisor, Hanspeter. Okay, let's start. You really like to watch your sports game because you came here to see this talk. Have you ever had a question while watching a sports game, such as basketball? So you may wonder about the player's information, who is Stephen Curry, or a stat question. How many points did he made like this? Or tactical question, what is offensive strategy here like this? So the Spotify can answer these all questions from the sports fans with the personified narratives and embedded visualizations, especially basketball. So as your sports fans, we are naturally curious about three main aspects: the players, the stats, and the tactics. So we want to know more about individual players, such as their careers or background. On top of that, how they're performing and how their stats compare. For example, we can see their field goal and 3-point percentage and how they're contributed to their team performance. On the tactical side, we analyze the game strategies, which help us understand the flow of the game and each player's decisions like this. These factors lead to our engagement with the sports. So we built a Sportify, a visual question answering system that integrates narrative and embedded visualization for explain tactics or other questions. So in this demo, user can ask a variety of questions to Spotify while watching this video clip. You may wonder about some specific player. So you can ask about who is the LeBron James here like this. And then the Spotify can answer about this. Another important explanation is stat explanation. So the user can ask about stat question. For example, how many did he miss the point in this game like this? On top of that, the most important part is tactical explanation. On the one hand, the Sportify provides a third-person perspective explanation, like a commentaries, and the explanation are provided by traditional chat box with embedded visualization. Let's see first person perspective.
Hey, Steph, I'm cutting up top to open the floor and distribute their defense.
Got it. Draymond making the pass now drawing their attention will definitely give us a better opportunity.
On the one hand, the Sportify can provide first-person perspective on top of or on bottom of the player and navigate the explanation like having conversation with the players like this. So players and stats questions have been extensively explored by existing research. For example, this question have been addressed by visual analysis systems such as Hoove Insight that show the stat information. When it comes to embedded visualization systems such as Omniaculous, it focuses on the watching experience with embedded visualization, adapting to game context to help casual fans better understand. So despite significant advancement, there's still gap in current research that needs to be filled. First, existing studies are mainly focused on presenting metadata and game stats. So our study addressed this gap by proposing a visual question answering system that allows fans to explore complex game tactics. The Sportify can answer all questions, including tactics, in sports video with a novel action-based visualization. And presenting approaches tend to offer limited engagement options, such as passive viewing or a passive watching experience, which fell short of the meeting fans' expectation. So Sportify adopts large language-based question answering techniques to create texture narrative coupled with an animated embedded visualization to create personalized visual storytelling, including first and third person perspective. Now I'm going to talk about the Sportify, the entire system. So Sportify works as follows. So it processes the videos and utilizes the computer vision pipeline to track the ball position and player position, identifying action like a pass, cut, screen, which are really important action in the basketball. It also classifies tactics, pin down screen or hog offense like this, building a classification model by using the K nearest neighborhood algorithm. And user queries are answered by a narrative agent that generates narrative from the extracted data in the first or third person perspective. The other players or stat-based questions are addressed by searching or data tools. Finally, we visualize these components using the embedded visualization with identified actions such as pass, screen, and cut. With all components are integrated, Sportify presents comprehensive in-game strategy and performance insights. Another aspect to consider is about action visualization. So we visualize 3 actions such as pass, cut, screen, which are really important action in basketball that can lead to the points. So we refine our design to optimize action visualization by removing the occlusions and emphasizing the players and involved in passing and receiving like this. For cuts, we precise marked future player positions with the flash forward animations. For screens, we visually represent them as a walls to clearly identify the settings player's position. Now let's explore user study about how we evaluate our system. So to evaluate the understanding, usability, and engagement of the Sportify, we collected information about participants' background, such as fandom level, through the pre-study survey. And the task 1 was conducted to investigate the understanding of strategies and the helpfulness of the visualization and narratives. To compare participants' game watching experience, we compared between a free exploration of the Sportify and tactic explanation video on YouTube. This figure indicates participant rating for each individual visualization helpfulness. All the three visualizations received positive rating from the majority, confirming the usefulness of the three visualizations for understanding strategy explanation. So we got a qualitative feedback. The one participant says that I sometimes miss who received the pass, but with the visualization, I could easily notice it. As you can see, this figure, it shows the usability rating for the first and third person perspective narrative designs. So this preference is attributed to enjoyment of the story-based narrative and the user interfaces. So first person enhance the fun and enjoyment, and while the third person perspective allow feeling, control, and formality. We also got qualitative feedback like that. So participant one mentioned that first person perspective checkbox comes close to players, which help me better understand tactics. Lastly, we compared our tool to existing strategy explanation video on YouTube. Sportify has higher rating than existing strategy explanation videos. So it enhances the accessibility and in-depth analysis, motivate user to engage more deeply with the strategies and the user. We found that participants liked its ability to generate infinite number of contents based on their question. Also, like one participant says that I felt most interactive and creative when manipulating the player's conversation like this. So this is end of my presentation, and thank you for listening. And the more detailed information in our QR code, please visit the website. And if you have any question, feel free to ask me. Thank you.
Thank you very much for this clear presentation. We have time for one or two questions, and I don't see one online. That's why I'm starting with one. So do you have ideas how to tailor the solution to audiences with different skill levels? Is that something you considered? I mean, you could have someone who is very knowledgeable, very senior, and someone who is new to that kind of analysis.
So we also conducted experiment with diverse knowledge of the fans. But usually many novel fans are satisfied asking about basic question. But on top of that, like expert fan, they usually try to ask about tactical question. So we may handle about all entire the knowledgeable entire the fandom level of the fans.
All right. And another question I had is, are you able to answer what if questions with your approach? I mean, there is a certain like a narration, but can you intervene somehow or?
Oh, we can ask we can answer about the in-game decision why the players did this kind of action like this. But the what if question or scenario could be one of our future work. Yeah. So maybe in the future we can handle about that kind of question. Thank you for.
Thank you very much. I don't see further questions on Slido. That means we can move on to the next speaker. And the next paper is Smartboard, Visual Exploration of Team Tactics with LLM Agent. And the presentation is given by Xiao Liu, who asked me to play a recorded video because there are severe problems with the internet connection that they encountered over the last days, which happened to a few students already. And that's why I'm going to play the presentation, and then we can see if we can handle questions live. And just as a reminder, there is a small delay between the YouTube stream and Zoom presentations. So it's better to ask the questions during the talks and not at the end of the talk. All right. I will try to play the video of the next paper, and we tested that before, so it should work without problems. I'm going to share video.
Hi everyone, I'm Ziao from Zhejiang University. Today, I'm glad to introduce our paper, Smartboard, Visual Exploration of Team Tactics with IM Agents. Team tactics are essential for success in any team sports, such as soccer, basketball, and ice hockey. In basketball, tactics are often represented on a tactic board, which helps illustrate the steps and variations involved. Analyzing these tactics enable experts like coaches to develop strategies that enhance team performance. At the same time, it allows fans to gain deeper insight and engage more with the game. With the availability of fine-grained tracking data, much of the current research leverages AI models for tactical analysis. For example, some studies use this model to simulate game trajectories and analyze corner kicks. However, user intentions are seldom included in these works. Visualization method has also been widely employed in tactical analysis, but this work's analysis is not relevant on the tactic board. Other studies focus on retrieving similar game situations. Their fine-grained analysis is still limited. Large language models excel at spatial temporal reasoning, making it valuable for analyzing player movement data. Its multimodal capabilities support both visual and verbal tactical setups, providing insights that connect multiple tactical steps to the final effect. So we want to combine large language models and visualization for tactical analysis. We face two main challenges in developing. First, using large language models for tactical design can be difficult. For example, in a pick and roll tactic, experts may interpret plays differently, so input customization is very important. Additionally, the decision-making process is complex, requiring reasonable output. However, LLMs may lack such domain knowledge. The second challenge involves reasoning through complex scenarios. Factors such as game time, score, dynamic situations, and complex player decisions all make exploration more difficult. To address these challenges, we interviewed 6 experts about their tactical design workflows. They start by analyzing real-game videos to gather insight. Next, they sketch and design tactics on the board, which are then tested in training sessions. Based on the results, tactics are refined in a circle until they are optimized. While integrating IM agent, we conduct a second interview. We expanded the workflow and identified 3 key requirements for the system: comprehensive tactical setup, reasonable tactical simulation, and controllable tactical evolution. Based on these requirements, we designed a framework for interaction with the agent. The user input consists of 3 parts. First, user interact with visualization elements to customize the tactical scenario. Second, they refine tactical details by sketching on the tactic board. Lastly, natural language input express their intentions and goals. Once input is received, the system processes it through several steps. It integrates domain knowledge to enhance the agent's response, generates prompts to get decision-making, and control the output based on the natural language input. During execution, the agent infers from 4 aspects: context, team, player, and action. Tasks are then broken down into recommendations, explanations, and evaluations. The output is visualized on a tactic board, giving user clear feedback and further analysis. Throughout this process, multimodal alignment integrates scenario and tactic information by linking image and text. To achieve this, we first established a coordinate system on the tactic board. We then extract visual elements, including player roles, actions, locations, and trajectories. After instruction, we embed semantic information into a technical representation. Sentence describes movement along a trajectory, while the second captures the past actions at specific locations. These two alignment templates helps form image text pairs. After processing the user input, let's see how the framework handles these cross-model paired data. To ensure the LM agent has sufficient domain knowledge for technical design, we use a retrieval-augmented generation process to integrate knowledge. This involves embedding knowledge documents into a vector store and allowing the agent to retrieve relevant information when needed. Our knowledge document contains two main types of knowledge. Tactic-based knowledge include the visual depiction of tactics on the board and explanation of the coordinate system. Scenario-based knowledge covers the player's physical attributes like height, weight, and speed. Statistical data, such as on-court and off-court metrics, and also relevant similar situations to help the model know more about specific behaviors. After integrating knowledge, the system generates a 6-part prompt to guide the agent. The role defines the agent's capabilities. The knowledge enables agents to retrieve from knowledge document. Also, the introduction of tasks. Each task has an output format. By recommendation, we specify clear actions and trajectories. Explanation and evaluation both require a brief summary, but explanation focuses on actions and objective. What's the action, what it may counter, and what's the objective? While evaluation includes objective alignments and the opponent's potential reaction. The recommendation task is built from the initial inputs. Those inputs combined with the recommendation output create the explanation, and then the combination of all three forms the evaluation. Finally, we use chain of thought prompts to reasoning. Based on the framework, we developed Smartboard, an agent-based interaction visualization system for tactical play design. Smartboard consists of 4 views: chat view, setup view, simulation view, and history view. The chat view allows users to interact with the agent through natural language. In the setup view, users can configure specific scenarios and sketch tactics. The simulation view shows the agent's responses, including tactical reasoning and variations. The history view records all tactics and interactions for further review and iteration. We evaluate our system by conducting 2 case studies together with 6 domain experts. Let's see one of our cases. In this case, the experts focus on analyzing San Antonio Spurs' hedge defense against Houston Rockets. The experts found that James Harden's strong shooting ability against defense, so it had a requirement for simulating pick and rolls involving Harden. After viewing 3 pick and roll variations, the experts noticed that Howard's screen creates a set mismatch, causing a great threat. To address this, he sketched a hedge defense and then checked whether the tactic works. The result shows that Harden may use the defensive pressure to draw fouls, which is the defensive team should pay attention to. After hedge, the expert noticed Howard was left unguarded. To fix this, he moved players to help cover Howard's car. And the system evaluation highlights the Howard's possibility of covering the half defense using size. Finally, the experts adjust the setup to have 1 more player recover after the hedge, and concluded a principle of hedge defense in this scenario. In conclusion, we contribute a extensible framework, an interactive visualization system, as well as case studies and expert interviews. In the future, we plan to generalize our framework to other team sports like soccer. We also consider utilize our system to collect dataset for further research. Thank you. I'd be happy to take any questions you might have.
All right. Thanks for providing the pre-recorded talk. I think that worked fine. I see there are 2 questions already on Slido. Xiao, we can try to do that live now. How does your framework generalize to other team sports? You mentioned that in the future work, but can you comment on what your ideas are?
Okay, it's a good question. And in our work, our framework is really more about interacting with the agent rather than being focused on any one sport. And in this work, we use the basketball as an example scenarios, but expand it to other team sports is totally possible. The main differences between these sports are things like the visual encoding and also the details of the tactical board, also the focus of the tactical analysis. For example, in basketball is more player-centered analysis, while the soccer focus more on the analyzing areas on the court. So we need to modify these kind of information to generalize our framework to other sports.
Mm-hmm. Okay, there is another question. Thank you. Which specific LLM did you use in your system, and what were the reasons for choosing it over others?
Okay, thanks for the great question. And in our work, we used GPT-4 Vision. It was one of the best multimodal language models at that time. Initially, we tried using only text input, although the large language models could understand some encodings. The hardest part was to explain the lines and also the areas on the court. They can be expressed very easily using natural language. And so to solve this problem, we use the multimodal alignment and set up a coordinate system to help the model grasp this concepts better. Now the multimodal capability of these models are much better than at that time. So in the future, we also plan to focus on how to improve and apply these multimodal understanding capabilities for getting better results.
Mm-hmm. Excellent. Thanks again for the clear presentation. With that, we can move from sports to finance. And the next paper in the session is FMLens towards better scaffolding the process of fund manager selection in fund investments. And the presentation is going to be given by Longfei Chen.
Yeah,
who will take
thank
it
you.
from here.
Hello.
Yeah, perfect.
Okay. Hello, everyone. I'm Longfei Chen from Shanghai Tech University. Today, I'm pleased to share our work on a visual analytics system that helps investors more effectively evaluate and select fund managers. Okay, let's start with some background information. By definition, a fund is a pool of money collected for a prospective purpose, often used for investments, and the person responsible for managing and investing the pool of money is called a fund manager. In recent years, the fund market has experienced rapidly growth, which indicates that more and more investors are choosing to invest their money in funds. And this nature leads to an important question. As an investor, who should I trust to manage my money? There have been some relevant studies in the past. In the field of economics, some researchers analyzed that fund managers' performance, like their persistencies or quantitative metrics. While the theoretical studies are comprehensive, their practical application remains scarce to better help investments. In the field of visualization, similar studies on financial data primarily focus on stocks or quantitative chaining, with little research dedicated to fund managers or funds. Due to the task-specific nature of financial data, it's hard to directly apply visualizations from other scenarios into our context. That's why we are proposing a new VIS system designed especially with fund managers in mind. Of course, there are several significant challenges that cannot be overlooked. The first challenge arises from the large number of fund managers in the market. Collecting, analyzing, and comparing their information is undoubtedly a time-confusing and labor-intensive task. Second, due to the uncertainties in the financial market, fund managers' performance over a century period is often the result of a combine of skill and luck. But how to distinguish between the two during the evaluation process is another challenge. Third, in the mature funds, investors cannot directly observe all of the fund manager's actions, such as increasing or decreasing holdings. This makes it difficult for investors to evaluate the potential risks. Finally, investors' preferences are highly devised and needs an interactive mechanism to facilitate the selection process. To address these challenges, we propose FMLens, and we collaborate with 8 experts who have at least 5 years of experience and conducted interviews to summarize the key requirements for the system design. Based on these requirements, we developed a system that includes both front end and back end. First of all, we gathered data on the fund and fund managers in the Chinese market from the public available sources. And in the system, our first goal is to give an overview of the large pool of fund managers by analyzing different attributes. Especially, we transform the cumulative investment amounts of each fund managers across the 90 primary industrials defined by the China Security Regulatory Commission into the high-dimensional feature vectors, and then use TSNE to project them onto a 2D plane. Here, each dot represents a fund manager with the color showing their returns. Users can use a Bayshore tool to further track the detailed investment preparations of these individuals across various industries. Next, the ranking view is introduced to display the fund manager's performance matrix, offering weight-based rankings of this matrix. And this will consist of 3 subviews. The first subview matrix table shows the change in performance matrix over time for each fund manager. In the table, each row corresponds to a fund manager and each column corresponds to a performance matrix. And here we selected 6 commonly used matrices based on the literature review and common practice. The radar chart on the right shows the distribution of all fund managers' performance metrics from the table. By hovering over a specific row in the matrix table, the corresponding line in the radar chart will be highlighted. And the weight control panel below allows users to assign weights to each matrix, which then ranks the fund managers in the table accordingly. To further check the historical performance of fund managers, we introduced the historical management view, which allows the user to experience all the fund management by a specific fund manager, both the past and the present. The main chart consists of 2 parts. In the upper subplot, the green line showing the fund's daily net value, and the yellow area surrounding it represents the estimated intensity of position adjustment, which we simulate using regression methods. And the lower subplot displays century information disclosed in the fund's quality reports. As we can see, below each report day, there is a rectangle glyph which contains 10 dots corresponding to the top 10 positions of the funds, and their positions on the y-axis are determined by their holding proportions. For each dot, we connect it to a square marker on the left. This helps prevent dots that are too close to make it difficult to distinguish. For stocks that appear multiple times in the holdings, we connected them with a line. This allows the user to easily see which stocks have been held long-term and which are newly added. Finally, each report day include a circle diagram where the radians corresponds to the fund size at that time. And the blue part represents the potential of the top 10 positions relative to the total fund size, revealing the fund's investment concentration. Let's take a look at a case study where an expert uses our system to find suitable fund managers. In the FM overview, the expert first noticed that the fund managers with high and low returns were clustered at the opposite ends of the curve. And the expert was particularly interested in the difference between these two groups, so she took a closer look in the summary chart. Then she found that management in Group A were heavily concentrated in mechanicians, which is the Industrial C, whether Group B had a more diversity portfolio. Next, the expert turned her attention to the members in Group A with the highest investment potentials in the mechanism. In the ranking view, she customized the settings and assigned weights in two different performance metrics. After generating rankings, the expert checked the top-ranked fund managers' performance one by one and made some findings. First, she checked the third-ranked fund managers, who is currently overseeing a large number of funds, but only one fund is highly profitable. Interestingly, this fund is much larger in size compared to others, management by this person. As a result, this manager's impressive performance metrics are heavily influenced by the success of this single fund, which tend to overshadow the poor performance on other funds. Next, the expert looked into the second fund manager and found that he had only managed 5 funds so far, with the earliest management record starting in 2021. She concluded that this fund manager lacks enough experience and his investment ability would need to be monitored in the future. Finally, the expert analyzed the top-ranked fund manager who has nearly 8 years of investment experience. During the analysis, the expert was surprised to find that whenever this fund manager started managing a new fund, its net value tended to rise. Consequently, the expert was satisfied with this fund manager's capability and damned him worth of investments. Overall, we believe this work makes 3 key contributions. First, it improves the process of selecting fund managers, filling a gap that current tools do not really address. And second, it introduces a multiple dimension framework for a more comprehensive evaluation of fund managers. And third, it provides a user-friendly interface that's more intuitive than traditional platforms, making it accessible to users with different level of investment experience. Of course, limitations still existing, and we hope to address these issues in the future work. That's all. Thank you for your attention. I would like to answer any question.
Thank you, Longfei. We have 3 questions already.
Okay.
I will pick the first one and then we can see how far we get. Did you consider funds other than stock funds, like fixed income funds, money market fund, and so on? Then the top 10 holdings may not be stocks.
In this paper, we only consider the quantity fund. That's the fund invest for the stocks. Yeah. And the funds maybe invest for the cash, invest for the other things we don't consider, yeah, in this paper.
Okay, then there is a question by David. How are the performance metrics of fund managers calculated? Can you summarize
Okay.
that again?
It's about performance metrics. In fact, fund managers' performance metrics over a given period are totally based on the funds that he or she managed during that time. And for instance, if a fund had 2 funds with returns of 10%, and 30% in the past months, his overall return will be 20%, which is the average of the two. And if we factor in the fund size, we can use the weight average to calculate the performance. And in our system, our user can adjust the calculated methods in the ranking view to implement this option.
Yeah, thank you very much again. With that, we can conclude this presentation. We are, I don't know, 3 or 4 minutes over time. The next presentation is again on finance. It's the paper titled Tracing NFT Impact Dynamics in Transaction Flow Substitutive Systems with Visual Analytics. And the presentation is given by Yifan Zhao. The floor is yours.
Hi, can you see my screen?
Yes, all good.
Okay. Hi, everyone. I'm Yifan, and on behalf of my co-authors, I'm delighted to present our work tracing NFT impact dynamics in transaction flow substitutive systems with visual analytics. Oops. Here is the agenda for today's presentation. First of all, what is non-fungible tokens? Non-fungible tokens, or NFTs, are virtual tokens exist on blockchains and compared with diverse digital or physical assets. While NFTs certificate rarity and authenticity in the digital realm, the explosive growth of marketplaces has revealed a critical challenge. That is, the lack of assessment metrics for the long-term impact of NFT projects, which often leads to misinformed decisions and substantial financial losses for stakeholders. Here, we define impact as a measure of a project's relative attractiveness and visibility within the NFT ecosystem. Our research aims to help stakeholders understand what makes some NFT projects really take off while others just fade away. To achieve this goal, we needed to address 3 challenges. First, how can we effectively model the complex substitution dynamics within the NFT ecosystem? Second, how can we visualize these intricate relationships in a way that is both informative and accessible to stakeholders with diverse backgrounds? Finally, how can we best empower stakeholders to integrate their unique knowledge and experience into the analysis? While existing research on impact dynamics, NFT assessment, and network analysis provides valuable insights, it often falls short of providing a flexible and interactive approach for understanding NFT impact. Current methods frequently rely on complex models with fixed parameters, limiting their usability for non-experts. Furthermore, existing network visualizations can be visually overwhelming and fail to effectively link transaction patterns to the underlying factors driving influence. So we conducted a mixed method formative study involving domain experts and stakeholders to identify key substitution mechanisms, impact attributes, and design requirements. Initially, a focus group with domain experts helped us define the research scope and select the most appropriate substitution model and key mechanisms for simulating substitutive networks within the NFT marketplaces. We then conducted an online survey to identify the crucial impact attributes for quantifying these mechanisms. To further refine our design, we conducted semi-structured interviews, gathering detailed requirements for our value analytic system. Based on the results from the formative study, we identified 6 design requirements for designing our multi-level value analytic system. At the market level, users can track overall market trends and observe quantified substitution mechanisms. At the inter-project level, the system recommends similar projects to users with high substitution potential. It also supports intergroup comparative analysis. At the project level, users can analyze the impact dynamics of individual projects over time and compare the growth patterns of different projects. Still informed by the formative study, we sampled 17 NFT projects that have been ranked as top tier on OpenSea from June 1 to November 2022 from 3 sources. That is, Etherscan for detailed transaction records, NFT Go for project metrics like floor price and sales volume, and X, formerly Twitter, for social media interactions. This dataset enables us to quantify the 3 core mechanisms driving substitution within the NFT marketplaces. With all the data collected, we established the minimal substitution model. At its core, this model calculates the mutual substitution rate, which measures the likelihood of one NFT project replacing another. This equation involves quantifying 3 key mechanisms. First, we have propensity, which assess the similarity between NFT projects by simultaneously comparing their high-dimensional characteristics. Next is preferential attachment, which evaluates the relative appeal of NFT projects based on the shared stakeholders of 2 projects. Finally, we consider recency, which measures the longevity of NFT projects by integrating their popularity and duration to assess their freshness in the market. Based on the calculations of mutual substitution rate, we quantified 2 other aspects. One is the mutual substitution flow, which shows the direction and intensity of stakeholder movement between paired NFT projects. The other one is the impact dynamics, reflecting how globally appealing these NFT projects are to stakeholders in substitutive systems. Then we've designed NFT Tracer with 4 views to support in-depth analysis of NFT market dynamics. First, the propensity analysis view features 2 components: the upper control panel, which enables customized analysis, and the lower project list, which displays the tabular data of NFT projects that were active during the selected period. Second, the mechanism analysis view presents group-based distributions of key mechanisms and impact values. We use bar charts to compare 3 mechanisms and impact across NFT project groups. And the parallel coordinate plots enable more detailed comparisons of individual projects within those groups. Next, the substitution view reveals market dynamics and identifies flows between NFT projects. At its core is a substitution wheel, a triangular node link graph within a cluster ring illustrating the system at play. The node link diagram uses multi-attribute techniques to visualize the flow between projects, while a vector layout reveals the growth status of each NFT project. This diagram lets users quickly identify groups of projects with similar upward or downward trends, as well as pinpoint projects likely to replace one another. Finally, the impact dynamic view offers a comprehensive perspective on how NFT projects relate to one another and how they evolve over time. It combines 2 components: the preferential attachment view, which reveals bipartite relationships between projects based on shared stakeholders, and the individual evolution view, which illustrates the temporal development of each individual project. To showcase the utility of NFT Tracer, we conducted 2 real-world case studies. In the first study, we looked at the growth patterns of both healthy and unhealthy NFT projects. We found that stable, gradual changes in the 3 mechanisms are crucial for a project health development. For instance, we noticed that the preferential attachment values decreased steadily in well-performing projects. On the flip side, a drop in stakeholders' attention can signal negative trends. In our second case study, we explored how NFT Tracer can refine investment portfolios by identifying and comparing mutually substitutable NFT projects. We discovered that similar projects are more likely to substitute for one another, as shown on the left. Substitution flows between group members with higher propensity values are thicker than those between non-members. Another key insight is that competing projects with similar mechanism distributions often have negatively correlated impacts. We also conducted a user study to assess NFT traces' effectiveness and usability. Participants completed 3 analytical tasks, and we gathered both quantitative and qualitative feedback. Their positive responses highlight NFT traces' potential as a valuable tool for understanding the NFT market. While we focused on the NFT market, this research has much broader implications. First, the rapid changes brought about by the late 20th century digital revolution highlight the need to understand impact dynamics in the fast-evolving world. Second, NFT Trace's adaptable framework can be applied to diverse creative industries, such as empowering researchers to uncover paradigm shifts in academia, identifying customer trends in retail, and analyze competition. Moreover, the flexible minimal substitution model allows for integration of new variables and adaptation to different domains by enriching or replacing attributes. To wrap up, here are the key contributions of our research. First, we developed a novel model that simulates substitutive systems in NFT transactions. Second, we introduced an interactive view analytics system for exploring NFT project substitution and impact dynamics. Finally, we conducted case studies for deeper insights and a user study to validate the system's effectiveness. Okay, that's all for the presentation. Thank you for your attention, and I'm happy to take any questions.
Thank you very much. I don't see burning questions on Slido, and that's why I suggest, for the sake of time, that we move to the last presentation. If you have any additional questions to Yifan, please put them on Slido or Discord, and I'm sure she will get back to you. Thanks again for an excellent presentation. And with that, we will get to the last paper of this session, Who Lets the Guards Out? Visual Support for Patrolling Games. And the presentation is given by Matej Lang. Matej, the floor is yours.
Okay. Hello, everyone. Can you hear me?
Yeah.
Nice. So, hello, everyone. Thank you for the introduction. My name is Matej Lang, and on behalf of my colleagues, I would like to present to you my talk on visualization of patrolling games. So the patrolling games, they are a concept in game theory where there are 2 players playing on a field. This field can be some sort of a map. And at first I thought that I would show an experiment at the original venue. But unfortunately, the hurricane came and flooded the venue. So the second experiment was supposed to be the second one. And as we all know, second hurricane came. And hopefully, as I'm using the Viennese museum as an experiment, we all cross fingers that nothing like that will happen next year. So the patrolling games. There are 2 parties playing it. The first is the attacker, whose goal is to perform some harmful action in the site. It can be, for example, stealing something or sabotage. You take your pick. And on the other hand, there is a guard whose goal is to patrol an area and to prevent this harmful action. The whole game is played on a graph where you would, for example, take every room, make it a vertex in a graph, and then all the connections will be the edges. And although this is just a theoretical concept, it can be very well applied to real patrolling scenarios. So how do we think about this strategy? The first idea could be that the guard follows a fixed route. Once an hour, they go the same route as they are used to it. However, with high-risk situation, there is a possibility that the attacker will just stay for a while. They will learn the route, and then it's not effective. The guard could then have the idea to every hour take a different route. However, as soon as the attacker acquires the schedule by, for example, bribing somebody, this also doesn't work. So the idea how to deal with these issues is to be unpredictable. Because if the guard doesn't know where to come next, neither can the attacker. And so to model this type of random behavior, we can use the Markov chain, which is a well-used model for stochastic processes. As you can see here, a very simple strategy where the guard could go from one side to the other. However, since Markov chain doesn't have any memory, it would be quite hard to go there because every step they would have a 50% chance of going back. One way to solve this would be to introduce the memory by duplicating the states, which will in effect copy the locations. And we can now keep the track where the guard came from and where they want to go next. Why do we want to visualize the patrolling games? The idea is that the researchers who come up with the strategies, they solve an optimization problem. They find some metric that they are trying to optimize. However, the issue is if the metric itself is flawed, then the optimized result doesn't make any sense. And to find out whether those solutions are actually good, they would need to see the result of this optimization, which is just a probability matrix. And this is quite impractical. So therefore, there is a potential for visualization. So how do we visualize the patrolling game? As we have seen, with a simple example, we can just take those multiple locations and just, for example, color them in the same color. However, this quickly breaks if we try to use a bigger graph. That's why we developed a glyph that's able to either show the location in a closed state where we see the location as just one unit, or in the open state where we can also see the memory nodes. When we try to close those locations, we also need to take into account the multiple edges that come in and out. And so we created an edge aggregation algorithm that's able to recompute all the edges. As you can see in the image, all the edges that would be inside the location now become the self loops that connect to itself. And the main important takeaway is that by closing any locations, by any aggregation, we can still create a valid Markov chain, which is very important. To lay out the graph, we use the Force Atlas 2 algorithm. In the image, you can see the forces that we use. And all the memory nodes inside one location interact only with each other, and then they don't affect other locations nor other memory nodes, which makes the whole algorithm easier to manage and easier to work with. To create a less clutter in the location, we introduce the new type of force called axial force, and you can see the results in the animation. There is one quirk that shows in the Markov chain. You can see it here in the image. The upper loop has the majority of the edges as 100% probability of going through. Which creates a visual bias, and it looks like this path is much more used. However, we can overcome this issue by computing what's called the stationary state. And this type of visualization now shows the real frequency, how often the guard goes through this path, which now shows the path correctly. We also created some additional tools to improve the exploration of the strategy. So first, here is the edge threshold slider, which hides less important paths and allows the user to see all the details of the major paths in the strategy. It also detects any locations that would now be inaccessible, and it collapses it as well. I will play this again just to so you can see it. Then for inspecting how often or how long does it take for the guard to return to its original state, which is very important. If the guard left, how long does the possible attacker have for their malicious action? We have the recurring visit graph, so we can either see the location itself, or we can see any pairs of locations. How long does it take to get there? We also created the agent simulation, which enables to see the strategy in action. The most importantly, it shows the probability distribution in time and how it changes for the guards. And lastly, we show the transition matrix, which is the original point for the researchers. They are used to working with this type of data, and so they still have the connection to the new visualization. So in conclusion, I have in our paper we show what are the patrolling games. We show how we visualize them, and we present the algorithm for aggregation of Markov chains. In the future, we would like to focus more on this aggregation because we can create a hierarchy of a tree-like structure for the Markov chains, which could be used elsewhere, for example, in biology. We very much like to focus on visualizing multiple guards, because we cannot just simply reuse the same types of visualization, and we would need to come up with different types of representation. And we also want to apply the results in practice, and currently we are in discussions with the Czech Armed Forces who expressed their interest. So in conclusion, thank you very much for your attention. If you're interested, I'm looking for work. And if you have any questions, I'm here to answer them. Thank you.
Thank you, Mate. Excellent. Great work. Congratulations again. We have time for one quick question. I don't see anyone on Discord yet. My immediate question would be, so with design studies, it's always interesting to look at what can be taken away for the community. Are there any takeaways for network visualization that you found?
Yes, for the network visualization, I believe the main addition is the axial force, which works. It doesn't work perfectly for every scenario, but it creates another way how to declutter the hierarchy in the opened location.
Mm-hmm. Yeah, cool. All right. Thanks again. Thanks again to all speakers also for making it a very smooth session. If there are additional questions, please put them on Discord or reach out to the authors individually. And with that, I'm closing the session. We are almost back on schedule, which is great. Thanks again, everyone. Have a great rest of the day. Bye-bye.
Thank you very much. Bye.